All right, so I'll be hosting the session from code to conversation, emerging AI interface patterns for spatial data and analysis. What this session really is sort of an acknowledgement that AI is going to change our interfaces. An acknowledgement that most of us are already playing around and have applied this to our own workflows and are now thinking of potentially building our own geospatial AI harnesses. And already as through my development efforts or the development efforts of my team or just people I'm talking to in general, most of us seem to be reinventing similar ideas, sort of redundantly building out the same ideas before standardization comes along. So the structure of this, the structure of the session is basically going to be going over a few projects that have been built, talking about sort of like the common contracts or things that we should probably agree on if we're developing our own. And it's an open discussion. I'm not defining that these are the important things. It's an open discussion. I'll be joined by two of my colleagues, Dr. Ozietkin and Brian Terry. I'll be giving a presentation of a ESIP Labs funded MCP. Oz will be talking about its use in a harness as well as some of the UI considerations that emerge from that. And then Brian will be giving a more interactive and philosophical discussion about these general ideas about how our UI for geospatial is going to be changing. Hi, I'm Otto again. I'm going to be talking about map control. It's a model context protocol for controlling your map, or MC squared. The name is still a work in progress. I've noticed within this conference that multiple people have been showing off and taking their own approaches to building their own geospatial analysis harness for AI. There's a lot of things we can't trust Claude or these general purpose AI harnesses to do. So we're trying to build out our own geospatial harness, something that grabs information from somewhere, knows how to do an analysis or validate an analysis, knows how to execute on analysis, and then meaningfully display these results. Since the field of AI is still kind of nascent and we're figuring out how to build with it, the process comes with a lot of ugly abstractions, spaghetti code, and just the messy system in general. One of the things that we were struggling with is what to do with the map. We didn't want it to be part of the front end. We didn't want to be at the back end. Every time we made it part of either, it was very messy, and iterating on it became sort of a complicated thing. We kind of cornered a abstraction that we think is useful for decoupling the map from everything. And we thought about taking this to ESIP as an open source project, and we got a grant for it. So this is an open source project aimed at making the maps easier to deal with and more AI savvy. So this right here is sort of a motivating statement. Computer, analyze this mountainous region for forest, report back on their health. This is kind of the holy grail of if you're building a system, it should be able to do this, and you should not see any of the code ever, but you can see the code if you want to, obviously, but people don't want that much control when they're starting off with an analysis. Maybe you can fine tune that or dig around and specify later, but everyone wants answers to this and then wants the system to do this. And I've seen multiple people propose work on, and with Element 84, I saw like sort of like a tool wielding sort of approach. Some people can go with like a code generation sort of approach. So people are figuring out the thinking, but the map is usually like an afterthought or a thing on the side. Or at least it was for us before we start working on this. I can't speak for others. Analogy is a Star Trek computer. We decided to focus on the thing that zooms around as it's doing the analysis and shows you what's happening. So what we've built exactly is just like a map. It's built on it's built on Map Libre. It's like your traditional GIS map, but we've added in an architecture and a proxy system to get you to be able to control it. You can puppeteer this map, move it around. If you generate code, you put the little calls to updating the map and it zooms around for the user. If you attach it to an MCP, then you can get something like Claude or whatever to control the map and zoom it around. What that looks like is this. We're able to change the base maps, control the zooming, change the base maps again. This is open topo. Switch to satellite imagery. You can give it the 3D layers and the tilt, and the cameras control them. Add these interactive glowing areas of interest. Add the Matterhorn, Zermatt, and then like the snap, tilt. All this, by the way, is running on that system. There's a server somewhere that controls this this front end UI, and this entire PowerPoint presentation was sort of I would say vibe coded into HTML, so you can embed these things in there. So this is running on this system. In the back end, the interface to it looks fairly simple. Through a Python API, you can add a point, polygon, path, arcs, geotiffs, and we're working on supporting things. We're working on supporting multiple things that DeckGL or Map Libre might support, so you can build a more interactive visualization. These are also embedded instances of the map with stuff added onto it, just to kind of showcase like the sort of glyphs that you can add to it. A lot of geospatial primitives, but if you put them in the right order and you kind of puppeteer or stagehand this correctly, it looks like it's enough for a very, very cool interactive visualization. Some of these examples are trains, bugly, tile layers, adding geotiffs, batch add things, not one at a time. And there's also a drawing feature. So you can draw on the map and the MCP can report, oh, the user drew this thing on there. That might be a useful area of interest rather than guessing as to what the user is dealing with. Also included in here is the ability to screenshot your map and send that context to a vision model if you wanted to. Important thing to note here is that like this map is no thinking at all. It's just built to be used by things that can think of what to do with it. Structurally, there are three things you pay attention to, or three components of this. There's this map server. It's not on the front end, it's not on the back end, it's its own thing. You attach it via Docker or you attach it on the side. It's like when you start a project, someone's already built out the database, you just host it or whatever, you host the map server. The map server gives us a user interface and manages sessions between users and their map. We have a Python SDK. So if you're generating code, you can slip in the map control stuff. You know, you're already generating code. Doesn't cost you extra to make it interactive with the map. And then an MCP, which basically is, you don't want to go the code generation route, but you want to go with, let's say, the general purpose agentic harness, grabbing tools and controlling it through the standard MCP planning format. So the Python SDK is pretty simple. This is going to be a lot cleaner once we add it to PyPy, but you install it and you point it at the map. Instantiating map is simple. You import from this map control library. You create an instance of map control. You point it to the this broker or this map proxy service that we built. You instantiate something. You can instantiate with a custom name. You can say this is the user 12345's map. So if you're zooming, you won't be zooming someone else's viewport of the same map. So you can support multi-users on the same map. Multiple people can collaborate on fleshing this out. Then you print out the URL of this map, open it, and you can see it in a browser. But really, you would just embed this as an iframe the way I've done it in this presentation. Then As you're running your analysis, you can set like the base map. You can compute the geotiff of this is Sentinel band 1, and then you can just kind of add it to that stage, so to speak, this thing that's being populated. You can add a glowy polygon, and you can manipulate zoom stuff, zoom animations. So this is just kind of laying out set base map, add geotiff, add polygon, zoom to assets, and just print a URL if you want to inspect it or if you want it to embed somewhere. Part 2, MCP. The simplest way to think of MCP is it's just a nice wrapper for the SDK. It's built for general purpose harnesses. Everyone knows that you have like an API endpoint, and that there's probably going to be you're probably going to need a way to make it easier to manipulate or work with if you're sticking an AI onto it. So an MCP, you can think of it as like an extension of a traditional API with a lot of usability affordances for the AI harness or the AI system that wants to wield these tools. How does it really differ from an API? An API is going to have dense representations. Event ID, type, asset ID, created at, data can mean anything. But your system has specific business logic and specific context. So what MCP is like, yeah, sure, define all of these things in your schema, but draw out a very, very detailed natural language description. Your input schema, describe what sort of polygon you want or what sort of feature. If you have a style or whatever, a style setting for glow. Glow means it pulses the outline, or label means this is the text that we place on it. You want to leave as little ambiguity for the AI as you possibly can when you're defining things. So that's MCP is a standard that asks for that. And since it's such an API, you really just need to you really just need assurances that you describe your list of tools that you want the AI to wield. And you go through that description that I showed you, that you have an endpoint so that you can discover that this is an MCP server if you try to plug it into Claude or OpenAI. So basically just a way to discover. And resources. If you have something like a geotiff and you give it to an AI, it won't know what to do with that. It's just bytecode, incomprehensible thing. However, if you get back that you have a geotiff here, but it is, of the Carpathian Basin in 2024 and it's undergoing drought stress, that's a lot of context, and an AI wielding descriptions of these dense files that's passing around will know what to do with it. So resources and abstraction that you put around assets being produced or assets you want to consume or pass around between different tools. And then transport standards, but that's a more detailed technical thing that I don't know how to get into. So here's a demo of how this does work. When you deploy this stuff, you can deploy it locally. You can deploy it locally with its ability to handle things securely using like token passing and standard authentication stuff. And then there's like a third deployment mode that's like the keys involved. So user management system, an admin logs in with the admin password, changes his password, and then allows people into the system. This is off running on AWS right now. If you're logged in with this deployment mode, it'll give you what your public-facing URL is going to look like. It's going to give you some instruction on how to sign in, and depending on what your client is, let's say Claude or Claude Code or ChatGPT or Client or other clients will have usage instructions on how to add them. So let's go ahead and add them. Go to settings, connectors, This is just me showing an example of it being added to. Oh, so pick up. All right, let's prove me for this. Looks like I already gave that URL in the past, and it's telling me so refresh or something. You would just provide that URL that I copy and pasted. Yeah. Well, I kind of glanced over it, so that's completely fair. There's more than this. It's been a while since I've updated this specific page, but you can create a map, add GeoJSON, add GeoTIFF, zoom, set the base map, set themes. Up the font. Okay. Yeah, create map, add GeoJSON, set base map. There are a few things in here like take screenshot. Yeah. I'm sorry. Oh, it's like ESIP fed /MC2. At the very end, I'll have a large QR code, and that should be scannable for the. I'll also have the link as well written out. So it's added. And this is just an example of a general purpose harness using this. If you build your own, it might make a bit more sense than the flow that we have here. But let's say generate a blank map for me. Also give me the link to that map. Yes. There we go. I've described what the tool is in the MCP and that it can create maps. We're going to create a ticket out of dark mode. Yes. There it is.
Do we have any keys, users?
And I had to read them.
Oh, that's not. Oh, that's not.
Yeah. I'll ESIP fed. Yes, /MC2. All right. So it's created a map here. What this really is it'll give you like this URL to a specific map session. If you zoom around, add things or whatever, or what have you, you would basically only see those changes on this specific map session. So this is what that is. In fact, I can, thanks to Arc browser, I can do side by side like this. That's so let's try piloting this. Let's zoom to Budapest. Enter. If you integrate this, this would be embedded in your application. We zoomed there. All right, let's add a label to a attraction on the Buddha side. So let's go ahead and do that. No, it absolutely does not. Good catch. But there we have it. Buddha Castle. There's a lot of context about the world that your Claude already knows, so it's doing me really well in this demo. But this is sort of an example. Right now, it's kind of pedantic to have to write it out yourself of what you want to do. The hope is if there's a geospatial harness out there, it starts thinking about what a user wants to see without asking the user and piloting this for them in the background. Dare I? Let's see. No, I can't. This one? All right. Okay. All right. I'm not going to dance this dance with the disappearing thing. I should try that. Where was I? All right. So that was a demo of just, all right. So here's the architecture, the map server. So I mentioned that we don't want it on the front end. We don't want it on the back end. We kind of want it on the side supporting whatever. The back end might talk to it. The front end might rely on it, but it's its own thing. Complete domain isolation. So this is just describing that. What it is it's an event broker. So if we start with our MCP clients over here, our Gemini, our Claude, our custom harness, we hit the MCP endpoint. The MCP endpoint is basically a wrapper for just a general purpose API endpoints. If you use the Python SDK and you're into code generation, then we're hitting the API endpoints anyway. And then everything, a map zoom, adding a polygon is sent to a sort of like an event bus. And for every map that we create for specific users, like a map session with even a user as a key as well. And then you add references to polygons, TIFFs, GeoJSONs to it. Okay. And the map UI is when you visit the link that references the session and do the authentication stuff or it's a secure connection or what have you. Your map is going to have a ton of code on there that's polling this event. Someone sends a zoom, it gets back a list of the new unreacted to events, and it zooms for that user. The cool thing about this is we handle all of the state for this map. If you want to restart from where you last left off, you don't have to think about it in your front end. You don't have to think about your back end. This thing thinks about it. Give it the session ID. It remembers all the events that were fired, and you can rehydrate, so to speak, your old map session. We never store anything like a polygon or a TIFF or a GeoJSON here. We store references to it. So you're in charge of generating a URL for your GeoTIFF, or in the future when we support it, like ZARs and what have you. Yeah. So that's basically kind of the gist of it. There are other endpoints that aren't part of the tooling. We do have streaming of like your viewport. So you can actually, that's part of the tooling. You can grab your viewport at any given time. So if I say, show me something over this area is no longer ambiguous. We know the viewport of the user. We can get an event log. I should have included here that we have built-ins for what happens when you hover over something or what happens when you click on something. But we intentionally decided not to skin it and let people with their own AI coding tools kind of figure out what the UI is going to look on top of this if it plugs into this. So we want to support things like ZAR stores, cogs via tie tilers, stack items, PM tiles. That's that. And then setup. There we go. Setup is easy. Don't copy this verbatim because this is changing. We're still deploying it to the public repo. There's stuff on the public repo, but we haven't had an end-to-end test of whether this works. So the server is simple. It's an image that you add to Docker. Once that's up, you just get the URL of your hosted thing and plug that into the MCP. The MCP client or consumer, and the SDK is The SDK is going to be a UV add from PyPy, but right now it's directly from the GitHub server. What hosting looks like, as said, you open up your Docker Compose, you add the map control, you add a reference to the image that we're using. You configure reports however you want to. There are a ton of environment variables that you can put in here, but the most important is what your public URL is going to be. It has to be a public HTTPS for Claude to be able to consume it. And then everything else you want here, like your volumes, map data, etc. All right, now the juicy philosophical stuff. If you roll your own, there are a few things that we thought were cool that you should probably include in there. And one is the concept of vision awareness. It would make a lot of sense for what we've discovered is if you pass in something on your map to a third-party vendor of computer vision or through a strong like vision model, you can generate a lot of interesting context. So you'll never get from an analysis that any sort of rote deterministic analysis, the words, the burn scar southern edge stops abruptly right at the urban fringe, along with what looks like roads and fire breaks. That hard boundary between red pixels and rooftops shows how close the fire came to dense residential neighborhoods. Then it says a bit more. It even knows about the city more specifically. The lower 2/3 show Izmir proper in natural color, tile roofs wrapping around the teal green Gulf of Izmir. The dark swirls in the bay are sediment or algae, not fire related. So that's cool. That's already a lead to the next analysis if your AI is a thing that proposes the next analysis. And then false positives. The scattered red and yellow specks over the bay and the shoreline are almost certainly spectral artifacts. Burn indices misclassify turbid water, wakes, and sunglint as burned. The whole white blobs at the top are clouds. So it's even adding context for QA or notifies the user, don't worry about these, or the AI system not worry about those. So vision awareness, the ability to take a screenshot of the map is something that's baked in. And it could be part of just the more general purpose loop of like mining as much context as you can from the map. This is sort of a complicated slide. The idea is we've provided very, very simple glyphs or ways of like playwriting. And I'd like to think of it as like a stagehand, kind of controlling and puppeteering this stuff. So if you set out little cues or ideas and you stuff it into context that you want it to act this way when it's doing that. When you zoom or you indicate something of urgency, you want to add a glow. When you want to do this, you want to do this. And you create like maybe dozens of these cards about how you want it to treat individual things. And it's really good at extrapolating. You don't need one global system prompt. You can even do on a per analysis case. If you're analyzing wildfires, do it this way and visualize this way. And this just shows like if you add those in there and you generate code, it knows how to slice and add things into the stage, manipulate it. All right. Resource awareness is simple. What I said about geotiffs probably need more. Geotiffs probably need more than just the name of the geotiff. Annotate it and figure out how to do that such that not just our tool, but other tools can do that. Base maps probably need annotations too about when it's appropriate to use them. There's an open question about layers. And the question is, our GIS tools probably have way too many controls on them. And how much of this are we willing to give to the AI that's starting to puppeteer the map for us? It used to be that you have to kind of look between this and that layer, but what if some system is smart enough to make those decisions for us? All right, here's a final set of slides, and I'll hand it over to Ozyekin. The contribution process is simple. I should have worded this less bluntly. You would create a fork off of the ESIP fed. You would do whatever feature that you want to, and then you would pull request into ESIP's MC2. We have a Discord. We're a fairly casual group of people. We're four. There's four of us. We're open to cautious and considerate vibe coding. And since this is a fairly new project, the moat between core developer and a technical community is not really that big. We're still figuring everything out, and we're going through a hardening phase of making this more of a sturdy and durable open source project in the next few months. There's definitely room for people to grow. So if you're talking in the Discord, you're already a top contributor. And we are thinking about time series. We're definitely hardening, but most of the discussion about what's next should happen on Discord. All right, thank you. Our next speaker is Oz.
Well, before I start, do you guys have any questions for Otto?
I would just make a question. Really cool.
Thank you.
I wanted to know when you're running the MCP, can it handle multiple maps from different at the same time as it just one?
So I've been mostly just testing by myself. So I can't answer that, but I can't see a reason. Like the payload for that is relatively light. It's just references and just constantly asking to the server. You can have multiple maps, and most of the heavy processing is the individual's GPU on their browser. I would think the rest of it is just updating the event queue, and when your front end and the JavaScript that's running on there pulls it and grabs up all the events that it needs to update the map with, it'll just handle it on the browser. So I can't think of anything that's super heavy. Actually, one thing that's heavy is a screenshot function. To accomplish that, we have like something that spins up like a mock of the map at our user's current viewport, and uses Playwright to take a screenshot there. But if there are front end things that allow us to do that more efficiently, then that should probably be where that shifts. But I can't think of any major performance bottlenecks yet. It has that separation, and you can also do multiple users on the same map, or one map for multiple users, or one user can have like 10, 12, 100 maps. It's really just about like the sessioning logic. One of the things that we kind of want to add is if multiple people are on the same map and we're gathering their viewports anyway, it'd be nice to have like little bounding boxes of like who's looking at what, kind of like in some of these other collaborative tools. Any other questions?
Hey, thank you, Otto. Hi, everyone. Can everyone hear me okay?
Yes.
Yes.
Okay. I am Oz Yetkin. I'm with Analytical Mechanics Associates, and I work with Otto and Brian. We're leading this session together. And I'll be presenting the tool that was the inspiration for this talk and for this MCP server. So this is a tool called EOGPT. Let me hold on. Just give me a second. I'm more of a Teams guy. There we go. So EOGPT is an open source, open science conversational framework for geospatial AI. It's been developed by a relatively large team and supported by David Borges from NASA's CEOS System Engineering Office. And that's my email if you have any questions about EOGPT, or you can contact Brian or Otto. The idea behind EOGPT is that we want to be able to enable geospatial analyses at all levels. We want to enable somebody who's a casual user, or somebody who's a decision maker, or somebody who's actually a geospatial analyst to have a conversation with an AI system, so that they can answer questions like, hey, how has my area's vegetation changed over the last 20 years? How has the temperature changed between this city or that city? How are the trends going? So what we want to do is we want to enable these analyses in a way that the frontier models do not yet. So our vision is that we have an EO analysis system with curated modules. We have about 36 different modules that we have curated, anything from creating geomedians to looking at turbidity to fire scar analysis, etc., that we're not leaving to the AI to just vibe code, but we are letting the AI do the orchestration with. It's targeted for this system is targeted for open source release in 2026, hopefully sometime before the IGARS conference. And it builds on community toolsets such as the Open Data Cube. We have modular repositories that we will be opening up to the public so that more modules curated by experts can be contributed. And we want to, the system can also look at external news sources. So what we want to enable here, and this is what Otto was alluding to, is like, what is the philosophy? How do we want to go about building this type of tooling? We want a conversational user interface, but we also want to have a geospatial visualization. So sometimes a conversational question is good. Like, is this summer hotter than last summer? That's a conversational question with a conversational answer. But if I ask, hey, how much forest did we lose during the campfire in California? It's a conversational ask, but the answer is best represented as a map or a table. We have various data access modules that we have coded into EOGPT. And the way it works is that it orchestrates processes, it orchestrates these modules using a frontier model as the orchestrator via Python code. And what it does, we have another AI watching the code that's been written, running it, and fixing it on the fly if it doesn't work. The whole idea, and I don't want to go into too many technical details about EOGPT because we're talking more about the map component here, is that a code generator generates code, refers to our modules, talks to the execution server, and the execution server repairs the code if necessary. In the meantime, this code can also refer to the MCP map component and add and subtract pieces as needed. I'll give a demonstration, and since this is a somewhat small group, I'm just gonna drive it, so forgive me, this is a research prototype. If anything goes wrong, forgive me. If you guys have any questions or if any requests, I'll take them. So right now, on the right side, as a part of our tool, we have the MCP map component. And on the left, we have a conversational interface. We actually have a lot of starters that we can start with, but I'm just going to choose something simple. Say, zoom to Austin, Texas. So EOGPT has several conversational intents. It has, an analysis intent where it will generate code. It has a map intent where it will directly derive the map, or it has a news search intent that will search a news story and plug it into your geospatial analysis. All right, well, we're in Austin. Let's see. Well, let's get retrieve the latest Landsat capture over Austin, Texas. And displayed on the map. So right now, it doesn't particularly have a Landsat retrieval capability. It does, however, have a Landsat retrieval module that it will write code to call. So what it's going to do now is it's going to understand what we're doing, go into a planning phase. We can actually kind of spy on what our AI is doing in the back end. And look at all the files it generates. And what we'll do is we'll generate code. And of course, since I'm giving a demo, it's going to be slower than usual. That's to be expected. And our idea was somebody who doesn't understand anything about coding or geospatial analysis can use this tool, but people who do understand can use it as a starter for their own analyses. We're also going to have a notebook export feature. So as you see, you can have, it's using the map control system. It's using the URL that Ado showed you, which is the URL being displayed here. And this separation of concerns lets us focus on the AI harness and not worry too much about the map, but also makes the map responsive. As you see, now you have the latest Landsat capture over Austin, Texas. We can look at the analysis tab and actually see this and download it as a geotip if we wish. Well, let's do something a little bit more interesting. Let's say clear the map. I hope this works. All right. I want to see what the vegetation around Austin looks like. Show me the NDVI around Austin, Texas. Now it's going to go look at our module library, retrieve our NDVI module, and hopefully put that on the map. Once again, it has the, and of course, as Ado showed, we have different base maps. We have, the satellite, we have the OpenStreetMap base map, we have another dark matter map. I like satellite. So this is one of those interaction modes where the AI is smart enough to decide what to put on the map, where to zoom, what to do with it. The user can give explicit directions, but doesn't necessarily need to. And here we have the, I can say, not only did it do the NDVI, which is normalized difference vegetation index for any of you who might not be familiar with it, but it took a screenshot and then fed it to our AI system, and it's giving us a summary of what this AI is. Okay, let's. It's fine. We have this. We can zoom out. Well, Texas is great, but let's go somewhere else. Zoom to California. So right now we're puppeteering it to California. That's great. Let's do something a little bit more sophisticated. There was a wildfire in the Washoe Valley on October 14th. So what this is going to do is this is going to call one of our curated wildfire analysis modules. It's going to fly over to Washoe Valley. And what the module is going to do is it's going to retrieve the Landsat capture before and after. And it's not just going to go with one Landsat capture. It's actually going to go several weeks before, several weeks after, create a geomedian, and then create a normalized burn rate map from that, and then put this on the map. So this is the secret sauce behind EOGPT that we're going to open source, so that you can take our fire analysis module that we spent a lot of time developing and use it for your own purposes, or contribute your own modules to it. And if anybody is curious, here is the code that it's going to be running. Here's the map control stuff. And this is the rest of the code. We have a geocoder module, an NBR change module, etc. every function, every piece of code has a function called run, so that we can actually rerun if need be. But here we go. We got the burn rate, and it's on the map. We can change its opacity if we wish. So this is going back to the question of how much control do we give the AI? How much control do we give the user? So we want to give the user the control to, turn these things on and off, change their opacity, and maybe export them. We have the ability to look at the code. We have all the geopolygons, the planning, the actual planning text, the actual plan the AI made. We can go to our analysis tab. Oh, well, eventually we'll be able to, and look at the analysis. And we have the AI actually taking this. And creating a statistical summary table, and then you're showing a before and after geomedian and analyzing it. So this is a sophisticated geospatial thing we can do. We can also answer other queries such as, something a bit more pedestrian. Let's see, Californian temperature dynamics. Let's compare temperature histories between Walnut Creek and San Francisco. So here, the AI is smart enough to say, hey, look, we're comparing temperature dynamics between two cities. It would be good to highlight the cities on the map. And here they are. And it's going to go to the Aero5 database using our Aero5 retrieval module and compare the temperature histories. Here, the map is useful for context, but the real output is going to be a CSV file and a graph. We also have other analyses using algal blooms, water turbidity. We're working with Geo to analyze some Brazilian, we have some Brazilian drought use cases. And we work with the NASA's Atmospheric Sciences Data Center to put in modules for retrieving ozone concentrations and other pollutant concentrations. Let's see. While I'm waiting for this to run, do you guys have any questions for me about this tool or about how it relates to what we're talking about in the larger context? Right, so now we got the temperature histories, and here we go. We got a graph, and we can look at the analysis tab and zoom in on this graph, and we can actually, once again, this is the user, we could actually talk to the AI to modify this asset, but I can, change the color scheme for this and use this for my publication. Turn on the legend, turn off the legend, etc. This was inspired by MATLAB. I love how MATLAB lets you do various things, but I don't want to take up too much of our time with the tool necessarily. So let's see. But this is what Aldo means by harness for controlling the map components. And I'll take some questions from the room and from the online participants, and then I'll turn this over to my colleague Brian Terry to tie it all together.
If anyone's a question, I can pass around the mic. Okay, no questions. Thank you.
That's either a really good thing or a really bad thing, and I think glasses is usually a bad sign. All right. Let's go to my colleague Brian Terry for the final part of this panel.
Thanks. Let me make sure I'm unmuted here. Thanks, Oz. I was intending to be there in person. Unfortunately, I had a family emergency, so this is going to be a little bit more awkward, and I'm going to kind of have to depend on Otto to drive for me. The hope was to kind of maybe open up the floor to a little bit more discussion and talk about at a higher level how the participants at ESIP see AI tools and what the contract between the user and agent should be and the tools that are being developed right now. Otto, are you able to pull up my slides and drive for me? And the room audio is kind of bad, so I'll need you to either relay what's going on, what people are asking and what people are saying. But I'll try to be as I can't hear you, Otto.
I might be passing the mic around for that.
Okay. Thanks. Yeah. So if we go to the first slide, so one of the first kind of observations I want to make is that there's a lot of design choices and philosophical questions that I think we need to answer as a community when we are designing these kind of geo AI harnesses. And I see three kind of core tensions to try to work through as you're developing these tools. And the first one is the tension, and they're not direct, tensions, but the first one is reliability versus capability. A tool that is has more guardrails, is on more of a track, right? When you do this, you can think of this as where, you have maybe a specific MCP tool that does something, or, and that you go directly to like a tool that executes or something like that. That has a lot of reliability, and you can kind of assure your users, of its kind of correctness. But one of the problems is that as you throw up more guardrails and more type checks, or maybe, as your system becomes more based on these tracks, you have less room for agents to kind of go off the beaten path or respond directly to user requests. And this kind of starts to impact the capability. And, you don't really, and for the reliability side, it's kind of exhausting to have to write a system that has, a bunch of conditional. The worst part of this would be writing a system that has a bunch of conditionals. So we want both of these, but it seems like they're kind of in tension sometimes. I think what we've tried to do, in the EOGBT and with the MCP server is try to strike a balance between this. And I think code generation has a lot to say for it, but I'll kind of save that more for the discussion. The second tension is, declarative versus imperative, is that I think different users and different classes of users have different expectations. So I believe that a lot of users like the declarative power of AI, right? We have these new machines, LLMs, that are able to kind of take our intents and macro and expand them into something that is functional. But at the same time, we are then surrendering a lot of the agency around the details of how that gets done. And when we're doing things that may impact people or, actually have decision criteria, this can be dangerous, right? So how do we balance that, like, sort of feeling of power and, kind of helping the user along versus being more imperative? And you can imagine a less experienced user, perhaps, leaning more to the declarative side, where they just have a general question of like, hey, we had the example of like, has the forestry just, decreased here, right? Or something like that. And that's almost more declarative, where it's like, I just want you to tell me something. And then there's a more imperative section where it's like, you might imagine an expert has a very particular idea of how you would calculate the forest or what data sources that they want used. And I think that's difficult to navigate when you're creating these harnesses, because different users have different expectations. And then the third thing is transparent versus magical, right? Which is that, and it's a little bit along the same lines, but it's more about what you're presenting to the user and what the user is able to see. Like, a lot of the kind of magical AI is where we're hiding a lot of the, it's like a don't peek behind the curtain. We're hiding a lot of the harness mechanisms and things like that. And any code that's generated, we hide. And we don't really talk about like specific services or specific data sources, right? And you can hide all those, and it makes for a very magical and a very easy to use interface, but it's also not very transparent. And so the question is, how do you just maybe strike the balance between like shoving all of the code that the AI generated and having people kind of read through that or approve, granular permissions? I think, if anybody's used some of the latest AI coding harnesses, there's this kind of, permission approval fatigue that you get when it's trying to ask to use a bunch of tools, right? But at the same time, we want guardrails. And so the question is, like, do you just make it magical and you let the AI take the wheel? Or do you try to be fully transparent about, like, every time it touches a file or modifies data or, selects a data source, do you ask for permission? So I think this can maybe be made more concrete. So if you could go to the next slide, Otto. I kind of came up with this idea of an example to, maybe provoke some of the discussion. And basically, in a simple request like this, there are a bunch of ambiguities, right? Show me is an ambiguity, right? Where it's like, hey, what does that actually mean? Like, how do we actually render show me, right? The system has to make a decision about that. The system has to make a decision about what you mean by flood risk, right? Along the Brazos and below Waco are both, you have some toponyms there, so it has to decide what you mean by Brazos and what you mean by Waco. It also has to decide what you mean by along and below. Those are kind of relative geocoding terms, in natural language. And then since 2015, we have to since the 2015 floods, we have to, basically identify this as an event. And then we also have to parse the date and saying like since, that time and come up with a time range here. And LLMs are remarkably good at this, but how you handle each kind of subsection of these problems really changes like what your tool is doing, and how reliable or capable it is, or how magical or transparent it is, or how declarative you can be when asking for something, or how very specific you need to be. So if you go to the next slide. So first discussion question, and we can kind of jump around, and if people don't have a lot to say, I think I have more discussion questions than we could possibly get through in the time we have remaining. But I refer to kind of the old problem as like the pile of layers. So when my opener here is when you watch a newcomer fail with the GIS tool, what are they actually failing at? And my answer to this is sort of a lot of times when you see a lot of the web tools and things like that, they're very capable, especially, you can add more and more data sources, but as you do, it requires a bunch of exploration and playing with it and understanding what's actually available in the tool. And, you can kind of start drowning in what I call the pile of layers problem. So I guess I'll open it up to people's experience. If anybody wants to comment on this or has any insights to this, I'm curious what, layers gets right. If we should stick with the idea of layers in these new AI tools, if that's like the correct paradigm, or should it be something more like an analysis session or a map view as being the right way to kind of like control the context? Yeah. What do you mean by layer is also a good thing. It's like a very overloaded term. I guess I'm thinking in a QGIS, ArcGIS kind of scenario here. Right. But so, yeah, if anybody wants to chime in, now's the time. And I don't know if I can hear you yet. So I don't know if you could. Yes, I can hear that. Maybe not.
We have one.
Oh, okay.
Hi, Brian. It's Corey Levinson. Sorry you can't be here. Good to see you virtually.
Yes.
I actually, since no one else was saying anything, I have a comment, but it was not on this slide. It was on one of the previous. Not that you need to go back, but it's just a comment on one of the earlier questions you had. Ooh, are we controlling?
Yeah, shoot.
You were talking about users and like, how do you know who you're really talking to and what level of flexibility or concreteness you want, and that's something that I definitely am struggling with when I'm thinking about building tools as well. And I think like where I've come with that is like, building that into, if you're working with like a prompting kind of structure where like your end product is, let's say, a skill or an MCP server, like thinking about where and how can you have hooks in to like pull that out from the user early on in a session if that's necessary, or have some same defaults, but like, take that as part of the tool usage process is really like setting up like who you're talking to and what their needs and expectations are, and then kind of like calibrating sort of the rest of that experience based on, and as much as you can structure that up front, the better. If you have a really clear idea of your personas and some little like sub context prompts for each of these personas of like how you want the LLM to behave, maybe that'll like help with the process. But yeah, definitely a hard question that I think is good to be thinking about.
Yeah, you've hit on something I wanted to touch on. If you jump to slide 9, Otto, which is I think labeled number 6, that's like the 6th discussion question. Yeah. This is one of the things here is like who gets to set the defaults with the AI tools, because a lot of times and this is just a recognition of a lot of the user inputs are underspecified when you're using an AI tool, right? And I think there's a real question here where who gets to set those defaults? Is it the data steward, right? If you're accessing a set of data, the data steward may have opinions about how you should process that data, right? The person who built the analysis tool that you're maybe employing for this probably maybe has other opinions. And then there's there's kind of the person who's hosting the tool for the end user. They probably know them best. They know what the use cases are in mind. And I'm not really sure when we're building AI tools or harnesses how we kind of think about this, but I think it's a very astute point that you bring up. I saw something from Jason as well. I don't understand your first question. When you say that layers are removed from future tools which uses AI. Yeah, I guess we could jump back to number 1 to address that. It's not that layers would be removed. It's that a lot of times we focus on maybe building out a layer that shows a particular thing or that's presented in a particular way. Maybe we're baking this into like a web map service or something. And I'm kind of wondering, we have to think about, there's going to be multiple things that are brought into a session that we're working with AI and working on that data. And I'm not sure if the right interface is to present a large number of layers to a user when we're trying to convey something, where, maybe it's better to present kind of a map session with a bunch of pre-debate context where a user could ask questions about something, and then maybe the UI can configure itself. It's really an open question. I don't have an answer. It was just something that struck me as maybe kind of an interesting opportunity to, build a new type of UI where we don't have users poking through layers, setting opacity, adding, another set of data kind of one on top of another to trying to answer the question, where instead maybe we, let them ask a question and then the AI can compose a visualization for them if we have this correct context and the correct rules set up for them.
We have one comment.
Yes, go ahead.
Yeah, this is Rich Signal zooming out, I guess, again, what Ogus and Otto, like, I'm a little confused about, the difference between the things you showed. Otto, did you show basically kind of the same kind of approach to this sort of like opening up this a bit so like you can bring any agent, and is that kind of the, could you just kind of characterize the difference between what you guys showed?
If I can take that question.
Yeah.
What I showed is a tool that uses the component that Otto showed. What we started out with was EOGPT and an integrated map component. In time, we realized that this map component could be abstracted away from the tool and be useful in and of itself. So the map component was built to actually fit into this harness, but we tried to make it as generic enough to be extracted from it. So what Otto has shown is the map portion of EOGPT, which we are now open sourcing for the community. Otto, can you add to that? Otto, you're muted.
Hey. All right. Basically what he said. But we wanted something that we considered is sometimes when you do projects, there's a bit of like coupling and there's like a bit of pushing on the individual components. And part of making this thing open source was so that there's like an air of like, you can't make this just the project. It really was supposed to stand alone. And if we were to ever pivot into something someone else is doing, we wouldn't have a tough time because it's general purpose enough. The way we wield it right now is we take advantage of the code generation and then slipping in map controls. It's very simple to do because you just add a prompt that says, if you want to control a map, or this is what this tool is, this is how you create a session. You slip that into your code generation prompt and it slides it in there. In the future, we'll be moving towards instead of like intent routing for the thinking, towards actually wielding it like an MCP. But we needed to make it an MCP first and validate it on a few other platforms to make sure that's there. So we wanted to give ourselves a lot of options. And if other people give their input and contributions to it, I think we can only like benefit from it. So it's we're not constrained by the shape of this project.
Well, one way of looking at this is that we are incubating this map component in our current tool and then releasing it into the wild.
Yeah.
Okay. I think if there's...
Okay.
Yeah, go ahead.
Yeah, just a quick comment, Steve Young, former EPA. The layers thing is interesting to me. And so layers are kind of a metaphor, right? And it's almost like a legacy of the old days when people were using the acetate sheets or whatever, and
Exactly.
writing on them and overlaying them. So I wonder if there might be another metaphor, and it's fundamentally 2D, right? Another metaphor that might capture the idea better, looking ahead and be sort of more 3D, conceptually than layers are. So this is a poorly formulated comment, but especially when you have these kinds of capabilities, it would be really interesting to try to come up with some alternative metaphors that might be more effective in this environment. So I just wanted to kind of throw that out there. I don't have an answer for that, but just wanted to throw it out.
Yeah, I think you fit it spot on. I think you're reiterating sort of what I was thinking about when I kind of put this slide up, which is the common language we use to refer to, like, maybe and maybe there are two different things here, right? So because like you kind of have like the user session, but then you also have like what you're working on in that session. And I kind of think that a lot of times what we're, maybe previously working on in a session is that like you've compiled a bunch of, as I was saying, like maybe layers or things, you've put stuff on the map, right? But when you start working with the AI, like you're actually probably need to have a more broad and expansive definition of what that is, because you may be generating code, you may be accessing additional data sources, you may be rendering out a visualization, right? And it should probably be a lot more flexible, and we should probably have a nice common name to refer to that with our tools. An analysis session is kind of a generic way to maybe say that, but and kind of figuring out what the shape of that thing is, I think would be really interesting as we go forward. Thanks for the poorly thought out comment. I don't think it was that poorly thought out at all. So I would go to the next slide. So one of the things here is one of the things to keep in mind when we go to incorporating LLMs into our tools, right, is that you have basically a text box. And there's this strong contrast between graphical interfaces and textual interfaces for the user, which is that graphical interfaces are very discoverable, but they're very rigid. And so, because there's like, okay, I can see that there's a button, I can click that button, but that button only ever does what I tell it to do. Whereas a textual interface is not that discoverable. I can tell it to do anything potentially, but I don't really know what's into the capability to actually type into it. And LLMs try like help us kind of obviate some of that. But I'm not sure how we make sure that how we kind of maybe solve that discoverability problem for things that are, maybe primarily text-based. In EOGPT, we have like this idea of starters. You can see in like OpenAI and Anthropic, they put like kind of like preset prompts within their text box to kind of help you understand what the capabilities are. And I'm also curious what needs to still be graphical user interface when we have an LLM. To me, drawing an AOI is like probably a thing that should stay. It's just easier to take the map and draw on it when you're referring to a specific area. So I'm curious if anybody else has either a time like an LLM surprised them with what it could do, or an idea of maybe what should stay a graphical user interface. If anybody has any opinions, I don't know if this is interesting to y'all, but Jason.
We have one.
Yeah, in our tool we chose to make like the actions that the agent is taking, the tool calls, the data that it's getting back, part of the graphic, user interface. A lot of other AI tools, you can hook up on the back end something like Lang graph, or it's not Lang. There's a monitoring Lang fuse, yes.
Yeah.
And then that's great for like the people who are operating the system. They can go back and trace through it, but it doesn't get exposed to the user. I like the idea of making that kind of things that the agent is doing. They can see that in a different way than just the conversation flow. And that also maybe goes to your last question here: is the conversation transcript the audit record of the analysis? Yeah, it's kind of like a Git commit history in a way, but sometimes you want to rewrite the set of commits in your pull requests before you push it because it doesn't make sense the way you got there. It's better to show it in a way that you're telling the story.
Right. Right. And I think as you have a conversation, you may be exploring and iterating, and this is sort of that iterative, whether it's declarative or imperative, right? As you try to develop something, it may be very imperative. Like you're saying, hey, AI do this, help me with this data, right? As you're going through the conversation. But then it may transform later into something that you want to be declarative, maybe for another user or something like that. So you can imagine developing like the forest fire module or something like that. I'm telling it, pull on this data source, do this analysis, whatnot. But then it transitioning later to something that's declarative. And I feel like the right balance to strike is that it's always accessible, but it's maybe not in your face like the audit part of things. But yeah, do we have another question or a comment?
This is Steve again.
Yes.
So something else is the kind of introduction of something that I didn't think about that is actually fruitful. Like, for example, if the system said, hey, you're interested in the burn, would you like to look at landslide data? Oh, well, that's indirectly related to the bird, but I hadn't thought about that. But actually, I probably should be looking at what we have on landslides. So, that to me, that's kind of cool that there's that potential to introduce things that I hadn't thought about that are, kind of off in a different direction, but potentially very worth analyzing.
Yeah, I think that's one of the real powers of LLMs is actually to increase discoverability in a kind of maybe not in the same way as like a graphical user interface, but in its ability to provide suggestions or next steps, especially for users that are maybe less experienced or trying to be more exploratory.
Yeah.
I guess, how are we doing on time here? We got about, by my watch, we got 10 minutes. Okay. Can we go to maybe the next one? Slide 3. Yeah, that's really small on my screen. Okay, so the idea here is that with LLMs and a map interface, you actually have two contexts, which is you have the context that the model sees, and then you have the context that the user sees, like in the map, right? And we basically have a synchronization problem here where, if you're asking it to do something, the model needs to have, if I've drawn on the map, the model needs to be immediately updated with what I've actually put into the tool, right? And one of the questions is how you do this. What is the appropriate way to do this? I come down on the side of kind of subscriptions are very important, and MCP supports the idea of resources. But there may be times where that's maybe not adequate. And this also should probably inform when you're creating something like an MCP, like what is the set of tools you do? And you should probably try to take advantage as much pushing, but enable pulling is kind of where I come down on that. I'm maybe more opinionated. But I'm kind of curious if people have had issues with trying to use AI with other geo tools or anything like that, and maybe if anybody sees any potential solutions, and should we try to bake into this, content, like some sort of content synchronization mechanism? I think with the map control, we've tried to heavily lean on resources, but does anybody in the room have any experience with this? If not, that's okay. I can continue to listen to my own voice. So if you go to the next slide. So this kind of goes, I guess, to what I view as maybe some of the general design principles that Geo AI harnesses may, this is not by any means exhaustive or anything, but these are some of my observations, which is that if you are synchronizing the context, there probably should be this one source of truth, this one context between both the map and the conversation. And you should probably have a lot of tooling to support that. The second one is that, and this kind of comes from, general automation principles, like with autopilots and, even the the cruise control on your car, is that the user should always have priority whenever arbitrating anything. So like, for instance, if the AI is trying to do something and you step on the user when they're doing it, let's say moving the map, that often is kind of psychologically injuring to the user, right? It's like you start to question whether you can actually control the thing. And so in my opinion, the user should always come first. Like the user inputs, what the user is saying should always be the primary thing. But this is maybe not as clear cut as we think, because sometimes an AI may actually have more context than the user because they can see directly, into the data or the state of certain things. So, but I do think we should always, in our harness interfaces, prioritize the user. The third one was kind of looking at like our subset of tools. Trying to make small subset of tools that have a general schema is probably the best way to go, where you don't have this kind of tool bloat. And then with the primitive level, like division of control between like the user and agent, this goes back to like having, an idea of like there is permissions for the agent, the user, and the system, where the system's job should probably be constantly updating the agent, where the user doesn't actually have to think about that. And then the last two is is that the kind of errors should probably not, like, there's this tendency when you start having code generation and things like that, is surfacing all of the errors to the user, is that errors created by the AI should probably be first addressed by the AI. And in your system, they should probably be denoted as such, right? And errors generated by the user maybe should be passed off to the UI, but, maybe they should be resolved. I'm not really sure about this, but like, I think you should probably have a system where you can denote what level errors get handled by, and having kind of distinctive error types. And then the last thing is declarative reconciliation. I don't know if that's like the clearest thing, but the idea here is that you should be able to describe how something should look, right? And then you have this idea of the step by step, right? That you should probably come down on the declarative side of things, and you just define what the end state should look like, and then let the system take care of the rest.
Sorry, we have one thought question response.
Yes. Yeah.
Yeah. Hey, Brian, Rich Signal again. I feel like on all these questions, you're not getting a whole lot of response, but I feel like you'd get a whole lot more response if we had all like played with this for half an hour.
Yeah, I may be leading the witness.
What?
I might be leading the witness a little bit here of trying to get some buy-in to some of the problems we're trying to tackle. But yeah.
Yeah. So just along those lines, I tried signing up, and it says, your name was added to the waiting list. What's the status of this? Like, when could we play with this, or do certain special people sitting in this room like get to play with it?
I'll let Otto take that, I guess, is probably the best person to.
Anything? Okay, I'll let Oz take that. Oz? The question is, where can people sign up for EOGPT and the MC? Oh, you did sign up. Oh.
So the answer to that question is we are still working on it. Watch for our IGARS presentation, I guess, hopefully. But the map component, Otto, that's a good question. We should be able to play with it now, right?
Yeah, I can approve it right now. Can I approve it right now? I mean, after this presentation.
I mean, you shouldn't have to, aren't we just putting this on GitHub?
It's on GitHub, but we've hosted a version of it so that we can do the Claude demo. We can open that to people with.
I guess it won't stay on forever, right? But we can open it for this session.
Yeah. Okay.
I don't see why not. I'd say go ahead and open this for the session so that people in the room can start playing with it and maybe come to you with questions. But the way to play with this, obviously, is to go to GitHub, clone it, and deploy it.
Okay. Well, after the presentation, I'll open up the interface and let people in.
Yeah. And
do feel free to send me an email if you're interested in EOGPT, and we'll contact you once we are closer to releasing it or finding beta users, which we're hoping to do.
Yeah. So I guess since with the limited amount of time, Otto, why don't we I'll leave y'all with two additional questions. So for the fifth thing, is that input understanding for these systems aren't really hard. You can go to the next slide, Otto. And there's a lot of ambiguity that has to be taken out. And I think what we should kind of work on as a community is understanding what the steps are for making sure that I think this allows us to be both capable and resilient, right? If we can, as a community, agree on what the steps are for resolving these general ambiguities in a user query. And then we already touched on number 6, thanks to Corey. And then I guess I'll jump over that to number 7 and say that there's really, with these harnesses, there's like a dial of how much agency the user should get and how much agency the AI should get. And this dial probably moves based on different things, such as like the operational cost, how hard it is to reverse something, maybe how much ambiguity is being implied by the question, right? Where you might have like a very knowledgeable user and it may be very apparent from their query that, a lot of the agents should be given from the user, but then maybe a very simple query, it should be interpreted as giving a lot of agency to the AI. But these are just open questions I wanted to pose to y'all. So thank you so much for participating. You can go to the next slide. Otto, maybe these conversations can continue offline or on GitHub or in one of the clusters. I really appreciate y'all being here.